Спасибо.
Спасибо.
Добрый день. Меня зовут Danny.
Меня зовут Стефан.
And that's all the Russian we know.
Yeah, after that it's going to be in English.
Okay, let's talk about dependency injection on Android. Want to start? Oh.
Or no signal. We have 2 talks. Oh. I can see your mouse. Yeah, okay. So here is Danny. So we know each other for, I think, for like 5-6 years. A DroidCon conference in France, I think.
And
Netherlands, yeah. And Danny is actually one of the cleanest coder I know of. Yeah, really, it's just amazing. I never saw so many short classes, short methods. Yes, just crazy. So right now he's working at Viacom. It's like 6 months ago he decided to leave Groupon, which was a very bad idea. But before that we were colleagues. And yeah, and he's been working just on crazy clean code, as I said, Kotlin. He even gave a talk this morning about it.
Okay, as he mentioned, we met in Amsterdam some time ago. Back then he was talking about RoboSpice. So if you were there in the early days of Android, there was an awesome framework called RoboSpice, and that's the guy who wrote it. And he did a lot of open source till then. He was maintaining RoboJuice for a long time. And lately he wrote a new dependency injection framework. And when I would have a question about bytecode weaving, annotation processing, and all the shit I never understand, I would ask him.
Yeah, and together we have more than 20 years of Java coding experience, so almost half a century. So I work at Groupon. Groupon is an electronic marketplace. It's present in Russia, so I guess most of you heard about it, maybe. And what is really nice at Groupon is that we have a big team of Android developers, like 40 in California, 15 in Romania, and we all work together, so it's like a big team of 55 developers. And what is really nice is that we actually have a lot of challenges related to technology, and we try to really remain cutting edge. So we use the best libraries, the best tools available, the latest version of everything. And we also have the opportunity to do some research during working hours. So it's not a joke. We don't spend our nights and our weekends for that. We are just doing it and being paid. So that's why we developed one of the library that we are going to present today.
So I'm working at Viacom. If you haven't been to the earlier talk I gave, like quick intro to that. People don't know the name Viacom, but they know a lot of our brands. So if you know Nickelodeon, you have a Viacom. If you know MTV, we own that brand. If you watch Star Trek, it's owned by Paramount Pictures. We own that too. So it's like a big media company. Our development teams are spread all around the world. I don't know, I'm working from Berlin. We have a team in Warsaw, our headquarters in New York. We have 2 offices there actually even. So it's a different environment to work with all those remote teams and all those brands. So we try to have like only a few Android teams working all of them. So it's really challenging. So check it out. But let's talk about dependency injection.
So today here is the plan. We're going first to talk about dependency injection at large, really an overview. What is the difference between version of control, everything. And then we will go through a small history of dependency injection libraries on Android to see where it began, what has been improved over time. And we will also talk about reflection, which is really a big topic on dependency injection, especially for performance. And then Danny is going to present 2 libraries that do not use reflection anymore. They belong to the new generation of the dependency injection libraries, namely Dagger and Toothpick. So Dagger 2 and Toothpick. And then we're going to focus on the internals. How do both libraries work? They both use annotation processing, and we will explain what it is about. And finally, a small conclusion.
Okay, let's start. So dependency injection. Who here uses dependency injection in their code base? Who here understands dependency injection? That's a lot, that's cool. So one thing that I see when people talk about dependency injection, there are a lot of those words. There's like dependency inversion, inversion of control, there's dependency injection, dependency inversion, and people kind of mix them up very often. These are different things that they work really nicely together, but they are different. So let's look into those. So dependency inversion is one of the solid principles. So if someone explains dependency injection with dependency inversion, he got it already wrong. It works nicely together, but it's a different thing. So basically, dependency inversion principle says that high-level entities should not depend on low-level details. Uncle Bob, who basically wrote down those principles, he always explains it with, think about IntelliJ, and there are plugins of IntelliJ, and IntelliJ has no idea about those plugins and the code that is in there, but they still work, right? Because they follow those principles. You could also think it in a different way. You could use dependency inversion. No, you could use dependency injection, as you all use it probably in Dagger, and still violate this principle. For example, if you would inject a SQLite database somewhere, you would violate this principle. Although using dependency injection, you're violating dependency inversion. So keep this in mind. But it's a different thing. The second principle is the inversion of control. For me, this is the underlying principle behind dependency injection. So in the end, it's about who initiates a message. And the idea is you know, especially for testing purposes, we need to invert this. So sometimes it's referred to this Hollywood law. Don't call me, I'll call you. So we invert the control, we give it back to me, and then I can define. This is very high level, and even the Hollywood law you can put on a lot of object-oriented concepts. So let's make it simple. Don't use new in your code. Why? Let's look at an example. Imagine you have an activity, and you have a tracking class that you need. And in onCreate, you just say, hey, track that started. So what's the problem here? The problem is this new. This class does two things. It uses the tracker, and it creates this tracker. Especially for testing purposes, this makes it hard. And this is the whole idea of the inversion of control. You know, we should take this new out. This class shouldn't know how to create a Google Analytics tracker or a tracker in general. It's not the responsibility of this class. So this is the idea of the inversion of control. This could be via dependency injection framework. This could be just via constructor, I mean, not an activity. But there are multiple ways to solve this. So dependency injection is not the only solution for inversion of control. A common implementation would be a factory. The tracker could be something like, hey, factory.create tracker. I would call this. And the factory would know how to create an analytics tracker. And it could give me a different one, right? Google Analytics, I don't know which other trackers you want to use. So move this out of your activity or any class. Another implementation is the service locator. It is very similar to a factory. It comes more like from the Java backend side. I could have something like this. Locator.get tracker.class. And there's some mapping that is normally wired up in configuration files or something that this locator knows how to create a tracker and give it to me. It's, especially when you think about abstract factory, this is a very similar pattern. And then there's dependency injection, which is the one we are talking about. And you all know this, hey, it's all about this add inject, right? So there are different ways for dependency injection. There's the field injection, the one that we just saw, right? There's a field, tracker, and we inject it. There's constructor injection. So if we have a class that needs a tracker and we would annotate this, I can, then this dependency injection framework or whatever you use would find this constructor and would know to create my class, this is what I want to use. There's also setter and method injection, which are not so common, so for now we will leave them out of this talk. So, how did the whole thing start?
Let's get back in the past. So we're just going to talk about, oh yeah, maybe you know the guy that I'm talking about here. I just took a quote. I'm not so sure that you heard about him. So here you can see that it starts with a dashed line. And what is the dashed line? So inversion of control, dependency injection, all that stuff got invented a very long time ago, almost at the very beginning of object-oriented languages. So we don't have a precise date, but quite probably someone even thought about that in Smalltalk. In Java, it really started with Spring. So Spring got started in 2002, but Spring actually is not used on Android. There is an Android port of Spring, but don't use that. Then the really first thing that is interesting to Java is really the beginning of Juice. So Juice 1.0 was released in 2007, which is quite a long time ago, no? Almost 10 years. So at this time, Juice is using annotation it's not using annotation processing, it's using annotations. So it's the first time that we see the @inject annotation, and you can use it for fields, for constructors. So everything starts to be created, being put together. And at this time, Juice was using reflection, and there was no issue of performance because everything was running on a server side or even on a desktop for a few applications. And so the reflection was used to create the instances of the things that you inject, and also to assign the members inside the main component. So when you wanted to create a dependency, you use reflection to create the instance of the dependency, and you also assign it to the guy who is going to use it. So that was the very beginning. It's Juice. A few years after Juice was running, getting mature, everything was working well, no issue in production, the people started that work on Juice. By the way, their names were mainly Christian Rubber and Sam Berlin. And so both of them they started to create a standard, which is a JSR, so a Java specification request. A Java specification request is an extension of Java. There is a committee, there is an approval process, a review, and the final draft was released in 2009. So 2 years after Juice was released, which is funny. So we start with the implementation, and then we define the standard. And so Juice, the library itself, became de facto the first implementation of the GSR 330. Then, 1 year after, RoboJuice was launched. So maybe you heard about RoboJuice. I actually maintained this library with Mike Burton for 2-3 years at Groupon. It originated at Groupon. So RoboJuice, yeah, it's not a good library anymore. We will talk about that. But at this time, it was just crazy. You're on a small device, a small phone, and you can use dependency injection. That was a huge progress for Android. So it's really the first DI lib for Android. It's completely based on Juice, which means it uses reflection. And at this time, RoboJuice was also growing much beyond dependency injection. We also supported stuff like binding views, also by reflection, what you do now with Butterknife, for instance, and binding extras, which now you can do with Dart and Hansen. And also, it was creating event buses and stuff like that. So it has grown into something very big, which actually, maybe if I can do a small parenthesis about that, if you want to create a library and to go open source, try to make it as sharp as possible. Don't grow into something like that. That's a very, very bad idea. You cannot evolve easily. You cannot solve bugs easily. So yeah, it was just too big and also too slow. So that's why 2 years later, Dagger got started, but only started at this point. So in 2012, we went back in the commit history, and the first one was in 2012. So the goal of Dagger is to create a dependency injection library that works completely at compile time. So it doesn't use reflection at all. We will go in depth on what reflection is. So it was the first compile time implementation of the GSR 330. Actually, even when we started to create the GSR 330, so in 2009, someone had the idea already that it was possible to create something at compile time, that it could not rely on a reflection at all. So from the very beginning, it was like an idea that some people had in mind. But it only took a real shape in 2012 at Square, and Jake Wharton initiated the project. Then, almost 1 year after, so you see it really took quite some time to really develop the library, Dagger 1.0.0 is launched, so that's a first milestone. It's a complete compile time implementation of the GSR 330, which means it has crazy performances compared to the RoboJuice. It's also very lightweight, and we will see in details how this can work. They use annotation processing at compile time, so it means that they generate code instead of using reflection. And the generated code is used to assign members and to create the instances. So when you create a dependency, you don't use reflection to call the constructor, you generate code to do so. Then, so we are in 2013, that was taking place at Square in California. Then 2 years later, some people from Google decided to contact the people from Square. So everyone had moved from one company to another, and most of the people from the GSR 330 were now working at Google, some of them at Square. So they decided to join their forces and to create Dagger 2. Dagger 2 was aimed to be even faster than Dagger 1, and also to have easier error messages. That's really the two main features they were looking for. Because in Dagger 1, it was creating very complicated error messages in case anything broke. So they wanted to simplify that. And the main development took place at Google. This is April 2015. So you see, it takes time, everything gets more and more mature. And in October 2016, at Groupon, we decided to completely drop support, actually a few months before that, to drop support for RoboJuice. We tried our best to enhance it, to make it faster, but there was a limit, and the limit was reflection, so we decided to go for something new, and we created Toothpick. So we released it in 2016, and it actually took like 2 months to develop it from scratch. And one of the ideas of Toothpick is that it has to be super fast, so it is as fast as the daggers. They are mostly in the same range of speed of performance, so Dagger 1 or Dagger 2. It's also a different approach, so it's quite a hybrid compile time and runtime engine. So we will talk about that, Danny will explain a bit more about it. And it is mainly more flexible, simpler, and it has an amazing test support, something that Dagger doesn't provide at all. Now, the situation is that there are many libraries doing that. So dependency injection got many people got familiar. Yeah, we could say that most of you use dependency injection. So many developers try to actually create new frameworks. We will talk about the technologies that they try to use. So you can see, for instance, Lightsaber for Kotlin, Proton, Feather, Tiger, which is an improvement of Dagger 2. So there are many alternatives now. But really, the most maintained ones are really Toothpick and Dagger that we're going to compare a bit later. So from the very beginning until Dagger was released, everyone was using reflection. So Juice is using reflection, RoboJuice was using reflection. What is reflection exactly? And why is it a bad idea to use reflection on Android for dependency injection? So when you edit some Java code, then you send it to the compiler, it gets transformed into bytecodes, then it gets interpreted by a JVM, and then you got a running application. Reflection takes place when the application is running, so during runtime. Reflection actually uses object-oriented concepts to represent objects, classes, methods, fields, annotations, etc. So the whole API is really wired in the same way that your brain is wired. So you've been taught object-oriented programming, and they are doing exactly the same thing here, calling the things by the same name in reflection. We will see that in a second. Also, reflection is an API to get a view of the runtime Java objects. At the very beginning, it was not designed to be used for dependency injection at all. It was used for RAID development, rapid IDE development. Basically, you put a component somewhere, and you got inside your IDE a list of properties that you can customize, and it will influence the runtime of the object rendered inside the IDE. So reflection was all about that. So it's about runtime objects. What is cool with reflection is that it's a standard. It is part of the Java language from the very beginning. It has been thought like that, designed like that. And it's relatively easy to use. So it looks like a good candidate for maybe doing something a bit beyond just customizing components and using it for dependency injection. So here is an example of dependency reflection. So you can see we have objects that like classes, constructors. We call new instance to create a new instance. Nothing really to talk about. Methods, you can get the list of methods inside a class. You can get one specific method by providing its name. Once you got a method, you can invoke it. So it's exactly the same vocabulary as we are all using when we talk about our applications. Same for the fields. You can get a field, you can set a field. Not so much, nothing really difficult here. But why is it slow on Android? So first, we should have a look at how it works on a PC JVM. So on a PC or on a server's JVM, the reflection calls are actually cached. So the first time you make a reflection call, it's going to be doing something a bit slow. But if you do the call like 10 times, 15 times, then it's going to get cached. So as soon as the JVM is going to see, oh, that's the same call I did before, it uses the cached version. And the code gets executed super fast. So there is no real reflection anymore after a few calls. They are transformed into normal code with what we call the just-in-time compiler. So it is a runtime compiler analyzing the code. It detects there is reflection, transforms it into true bytecode, and replaces the reflection call by bytecode. And the 15 calls, the number 15 is actually parameterized. So you can customize this value by using a property sun.reflect.inflation. Yeah, no one really cares about that, but you can see it on the screen. On Android, the situation is quite different. So we have two VMs first. The first one, Dalvik and Art. So reflection calls first are not cached. So they are never transformed into bytecode. So they will always be interpreted completely by the JVM, which will say, hey, what is this class? What is the DEX file associated to this class? Oh, you want a method, so I got to find this method. Then I return an object. I create an object of type method, and so on. So everything is super slow. It really takes time. There is no cache. Also, the DEX format is not efficient for reflection, because the DEX format has been designed so that everything gets executed quickly, but not to provide a view of what gets executed. So inside the DEX format, there are a few things that you can do by reflection that are very fast, but if the reverse mapping, basically, to know what is the method associated to a given name is slow. So this is one of the issues why it's slow on Android. And also at the very beginning, before Gingerbread, there was a huge bug inside the Android SDK, the operating system even, that made annotation very slow, access to annotations very slow. And we always look for annotations when we do dependency injection. What is the field injected with @inject? What is the constructor injected with @inject? So we always need to look for annotations, and that was very slow. On Android Art, that got completely fixed, so the bug is completely solved. Now in Nougat, there is even some reflection calls that are now cached. So after a few calls, they will be replaced by bytecodes, and they will be injected instead of the reflection call. So it gets a bit faster. But still, the data structure of the ODEX is not really designed for that. So it's still a bit slow. A bit slow, yeah. So how slow? The first thing we can mention is that not everything is slow in reflection. For instance, when you do a class.forName, you can see the numbers on the right side, the stack on the right side. So we can load something like 1 million classes in 1 second, 600 milliseconds on a Nexus 5 device, which is super fast. Actually, when you do class.forName, you don't do anything different than when you just use a class in a Java file. So there is no penalty for using reflection for loading classes. That is super fast, and it's still reflection. The trick is that class.forName is just going to call native code. So there is no penalty for that. In the same way, if you want to just scan a few fields, if you look at the DEX format or the ODEX format, it's just a list of fields, a list of entries inside a file. So you can quickly go through the list and get all the fields that are contained inside a given class. So this also is reflection, and this is very fast. So reflection is not like an evil in itself. But there are a few things that are much slower with using reflection. So again, using the same Nexus 5 that I got since like 5 years, it's so broken. So if you benchmark, you will see that if you want to access like 100,000 fields using reflection on top, on the left side, you will see that it's like 3 times slower than accessing a field directly. So you want to modify, to read a field, modify the value. If you do it directly, it's 2 times faster just using direct invocation compared to using reflection. So it is a bit slower to actually manipulate the fields. And we need that for dependency injection, because we need to tell the entities that use a dependency to actually be injected the real value of the dependency. So we need to assign fields, to read fields and set fields. So this is slower with reflection, and we should try to get rid of that. In the same way, when you want to try to call a method using reflection, you will see that it's like 50% slower using reflection compared to direct invocation of a method. So it's slow, but not like super, super slow, no? You can agree. It's just like a bit slower, sometimes 50%, sometimes 100%. Okay, it matters, but it's not such a big deal. What is really super, super slow is actually this, creating new instances of objects. And we need to do that all the time inside dependency injection. So when you create a dependency root, so some place, usually in your activities or in your application, you're going to start a graph of dependencies. One dependency will depend on something else, something else, something else, multiple dependencies. So it's like a whole tree that you're creating. And at every step, you need to create instances of objects, all the dependencies, and to assign them into their dependent and so on and so on. And creating those objects, calling a constructor, is very, very slow using reflection. I don't know exactly why, I did not dig that. I got a feeling it's related to also inheritance, class analysis, not so sure. But if you compare the numbers, it's just amazing. It's like almost 100 times slower when you do that via reflection. And that's really the main issue that we had in RoboJuice and in Juice. And that's really the main thing that they wanted to get rid of when they created Dagger. So now let's Danny explain the difference and the similarities between Dagger and Toothpick, who don't use reflection.
Yeah. Okay, so why those two? First, Dagger, because everybody is using Dagger. If you do dependency injection Android, you probably use Dagger 2. Some might be still in Dagger 1, and hopefully no one is still in RoboJuice, because it must be a really old project. And why Toothpick? Because that guy was working on it. And why do I present it? Because I didn't work on it, but I worked with it. And I worked in projects with both, and so I thought I will do the comparison to have a more neutral view. So, what do you want to analyze? Let's look at how we use both, how the setup works for both. The whole idea of scopes, which is very important when it comes to Dagger, we will look at. Testing, my favorite part. And of course, performance. We heard like reflection issues, so how do both perform to each other? So, how do we use Dagger? You use add inject, and let's go back to our tracker, and we just do this field injection, for example, right? Before this, we have to start building this component. So we have to tell Dagger, hey, can you inject me, right? It could be from an activity, for example. So you would use this class that is generated by the compiler, use this .builder.build.inject. You probably have this somewhere. Maybe if you have a good code base, you somehow trying to hide this in the class, but most people use this directly in the activities. Then you also might need to set up some modules which tell the system to create specific objects that don't have just an add inject constructor. So there are this concept of modules that Dagger knows. And you also have to connect them. How would Steve Toothpick work? You use add inject at the same field. Why is this add inject? Why is the same thing? It's the same thing in Dagger 2, in Toothpick, because they're all following this JSR. So the JSR is defining this. So add inject does not come from Dagger, it comes from basically a JSR namespace. It's a Java namespace. So the setup is a bit different. So you would still call add inject.inject this, but instead of setting up this app component, you would call something like open scope. And for example, it could be an application scope. So I use a string here to show you that this is about application, but it's basically any kind of object that basically is associated with the scope. About the whole scoping topic, I come to this later. So for now, just see it as the same thing that we just saw with Dagger, but just a little bit shorter. There are also modules in Toothpick. So if you need a module with specific classes, for example, how to map an interface to a specific class or something, you would install a module. It looks very, very similar. So you just add it to the scope instead of this component. Because if I remember correctly, the idea of a component is not in the JSR, and Toothpick is not following this model. So the whole setup, and if you work with Dagger, you know this, and this is the way it also gets annoying. And I always hope that I don't have to create like new modules, because it's a bit of pain. But what we have to do, we create these modules, right? And there's an annotation, add module. We probably need application context, because you need some context to we need a lot of things in our Android classes. We need a context, so very often you pass the application context. Of course, it could be like without if you don't need it. And then for everything which you cannot use constructor injection, so for example, how to map an interface to a specific class, you would create this add provides. So this is the method that Dagger calls when you need a tracker. So when you do add inject tracker, it would actually go there and find this method and gives you the new Google tracker. We are still on Dagger. So you have to wire this together with this component that you saw in the beginning. So you create this app component, for example. You wire together the component with an annotation and the module. And this is for me the worst thing in Dagger 2, because it wasn't like this in Dagger 1. For every inject call you need, you have to specify one of those. So for every class that wants to call add inject with like field injection, you need to have one of those. Yeah, it has something to do with how do we do the optimization compared to Dagger 1. So everything is really on compile time. Let's look at Toothpick. So as we saw, they also know modules. So we have a base module. We can also pass application context, right? It's the same wiring. But there's no add provides method here. So we could say, you know, if you need a tracker class, use this Google tracker class. And there are different ways of those bindings. You can bind to an instant, or you can bind to a singleton, something like this. So it's more like a bind to, you set it up once. via code instead of via annotation. So still very similar, a bit less annotation. So let's look at scopes. Even if you don't use activity scopes, which is for a lot of developers a big thing, you actually use scopes all the time when you use dependency injection, because you probably use an add singleton annotation somewhere in your code. Actually, what does it do? An singleton that you use without activity scope is part of the application scope. So it lives as long as your application lives. That's why we wanted to make it singleton, right? So you could think about a configuration class. A configuration class, a typical singleton probably in your application, in your Android application. But also there's like stuff like networking you probably would do with the application context, right? Because we don't want to leak activities. So in the last years, activity scope were a big thing. So it was kind of working with Dagger 1, a lot of custom thing, but Dagger 2 is more made for it. So the idea of the activity scope was, people like singletons, but the longer your app lives, the more of those singletons you all of a sudden have, and you only use them in one activity. So the idea is, let's have activity scopes, and there's a singleton, for example, that only lives as long as your activity lives. And then you could inject the same thing in your fragment on that activity and the activity itself. So everything that is UI related, right? You would normally use the activity context. So this is the whole idea of the activity scope. So you can inject your activity context and use that. So this is the difference in the two. Application scope and activity scope. And both libraries that we look at can handle this. So let's look at Dagger again. So you have to define, if you want a custom scope, an activity is a custom scope, you would define an interface like this. So this just say that it will be an annotation, and then there's an add scope, and you say what is the retention, it's runtime. Then you would use this annotation that you just created, and probably create another component, like a scope component, where all the stuff lives that you want in your in this activity scope. And again, right, we need this .inject method for the scope activity or something, because we want to inject there. Then we would probably create a module, because all the provides things live in a module, right? And we have to always use this add activity scope. And then we could use the activity and inject it. And when we need an activity, we can use the add inject in a fragment. Or the fragment doesn't make sense, but in a class that is kind of bound to the activity because it's UI related. So then we continue by wiring this together. So probably we create a method like this so that we can somehow tie the scope module to the base module. Yeah. So what I think about this, that's pretty annotation porn. So there was, I think, 3 slides full of annotation. I think it's actually 4. Just to creating a scope. We haven't even used it. So let's use this. So how we use this? We would go back to our app component builder, which is generated by the compiler. There's the base module that we saw. Then we call this plus method that we just created for the scope module, giving the activity. And then we would call finally inject. So now we are done. We just used activity scope. For me, and I like Dagger, and I've worked a lot with Dagger, but this is really problematic. I hate this. So let's look at scopes in Toothpick. So we call the same open scope thing that we called for the application, and say, okay, let's open another scope that just uses also the application scope, and I install one module, the scope module. So the whole inheritance doesn't need to be wired, because the moment I say open scope, I can say which scopes do we need to combine. And activity scope and application scope are basically used in the same way. And again, I use strings here, but this could be your get activity, and this could be your activity class. So that you use real instances. It doesn't have to be a string. And then you would call inject this. That looks pretty nice, right? So the only thing is there's also the scope module, looks the same way as the other one with all the bindings. So there would be another 3 lines of this. And this is the whole idea of scopes in Toothpick. For me, this is one of the big reasons to use Toothpick. So whenever I need to create a new activity scope in Dagger, I hope that one developer grab this task, because it's just annoying. So there's one thing, I think we mixed up the slides, about scope verification. So there is a difference here, how scope verification works. So what is scope verification? Basically, the dependency injection framework wants to make sure that you're doing everything right. That you're not injecting something that is not part of your current scope. There's a difference in how the two libraries work. With Dagger, this is completely compile time, so your compiler will fail. And you have this probably very often, that you have no idea what's going on right now, but you probably messed up the activity scope you wanted to set up. Because you're using add inject and it's not in your current scope. With Toothpick, this is runtime based. In debug, it will crash if you try this, not on production. So this was scopes. Let's go to tests. It's really easy with Dagger 2 because that's what Google says. Don't use Dagger for testing. People still want to do it. So let's try. So we could, let's think about back of our tracker. So we would mock a tracker class with the mock annotation, right? Let's Mockito, whatever you want to use. Then we somehow need to overwrite how this tracker gets created. So we will create our own module, extending the base module, and overriding this one method for providing the tracker, for example, and return the mock. This is how we can start, right? Then somehow, the problem is that your activity code would still go to the original Dagger app component that your test needs to override. So you have to write custom code that you can somehow replace this and make sure that your test module gets added there and not the base module. So you have to find a way to do this. So I do this my application.set here. Not the nicest way, but you have to find a way like this because your activity will ask Dagger for injection. So let's look at Toothpick. Toothpick, I would create a mock. And then I would use a rule. Not sure if we used rules. And if you use Espresso, you might know this. So there's a Toothpick rule, and you can just say, you know, for application scope. So use the same name as your scope. For application scope, use this rule. And what will happen is there is no provides method you need to override here. So every time that your code asks Toothpick now, hey, I need a tracker, it will totally ignore the original scope if it finds a mock annotation here in your test. So this rule actually binds all the mocks that you set up in your test with all the add inject in the test under class under test, sorry. So it's a bit magically, but it's awesome. So let's look at a more complex test. So let's go back to Dagger. How would you have like 3 mocks? Your base module would grow, right? Now you have to override 3 methods and with 3 mocks. The same thing in Toothpick. You have 3 mocks. Nothing changed here. Because we are wiring together all the injects with all the mocks. And the more complex your class is, the more obvious is that the Toothpick is meant for testing. As I said at the beginning, Google says don't use it for testing. Because there's a constructor, right? But the problem is sometimes we use field injection. So let's look at performance. We all use Dagger because of performance, right? So let's look at the cost of creating a scope or a component on Dagger. So as you can see, the Dagger and Dagger 2 roughly do the same. They need 20 milliseconds to create a scope. Toothpick needs 1 millisecond here. So the creation of a scope is something where Toothpick is super performant. But there's always a but. Let's look at the injection itself. So the things that you need to inject. Let's think about the tree of objects. So let's think about 1,000 injections, which is a pretty decent number for like a good application. I think the group on Merchant Hub has like 1,100 or something like this, which was already a big application. So you can see that all of them are pretty on the same speed. So Dagger 2 is the winner here, but it's like 2 or 3 milliseconds difference. So, but if we increase this to something that really goes crazy, like a really, really large app, I don't know, which is more like your whole Android system, there's this where you see that Toothpick has a problem. So creating of scopes is nice, but the injections, if the number of injections increases, Toothpick loses performance. So it's a mixed feeling. So let's look at this in a graph, and you can see that Toothpick is really good at the beginning. I think even there's a bug in the graph. It should look like this, but it fails when the number of injections grow. So as always, there is not a single solution for all your problems. So think about what you have and then choose your tool. And this is one of the reasons I think also we want to mention Toothpick in this call, in this talk here. So choose the right tool and not choose Dagger 2 because that's what everybody's using. And that's what you used in the previous project. So if you just take this out, it's fine. Because we saw there's a lot of dependency injection libraries out there. So most people don't even know them. They always use Dagger 2. But Dagger 2 has drawbacks. It has good points, but also drawbacks. But let's look at why is it like this, and how do both frameworks work. And that's the guy who can explain this better than me.
So Danny just explained the compared Toothpick and Dagger together. Actually, they are using both the same technology. So they both try to avoid completely reflection by using annotation processing. So we're going to talk about annotation processing, what it is, how it works, and why it is performant. So if we come back to the schema that we had at the beginning, when you edit some Java source code and get a running application, you can see that when we are compiling, this is exactly where annotation processing is going to take place. If we focus a bit more on this, actually compilation is even a bit more complicated than what we can see on the screen. So at the very beginning, we take the Java source file, then we pass it to annotation processors. The annotation processors is going to create some new Java source code, and both the original source code and the generated source code are passed to the compiler. So annotation processing is really trying to give a view of the Java files that you create. The reflection was trying to give a view of the runtime objects, and the annotation processor relying on Java files. So they see it more like a structured grammar usage, basically. So annotation processing is an API to get a view of the Java classes before they are compiled, which is a sentence that doesn't make any sense, because a class is compiled by definition. So just before they get compiled, you can still view them. That's the advantage of annotation processing. It is standard Java, so the annotation processing and annotations have been introduced in Java 5. I think no one was born in this room before that, so anyway, it has always been there. They use different concepts to represent classes. That's the main issue, is that the API is super difficult to understand. So if you want to try to write an annotation processor by yourself, we can talk about that, but you will see it's really complicated. You remember when we were talking about reflection? There were classes, methods, fields, instances, you invoke a method, super simple. But when it comes to the annotation processing API, then things are called like mirrors, type elements, executable elements. You just completely lost all the time. That's one of the biggest issue with creating an annotation processor, is that it's a completely different view of a Java entity, which is really not close to the way we talk about them. It's really more how you would talk to a kid, how you learn, for instance, to speak Russian or French or English. So you learn a syntax, the syntactic element, there are nouns, there are verbs. So it's a bit this kind of views of the language that the annotation processor deals with. So it's not easy. It's not easy to use. It's not easy to debug. It's actually a hell for real. So you just basically do not debug, you log more. You can debug, but it's quite a setup. And also, one of the biggest issues is that it's very difficult to memorize. So you create an annotation processor, you're so much into it, you work every day on that, that's so good. Then you just publish it, and then someone opens an issue 15 days after, and you look at your code, what is that about? And that's really what happens all the time. So annotation processors are really difficult. One good hint I can give you, because at Groupon we wrote I think now we have 5 or 6 annotation processors, even internally, that we use for our stuff, like A/B testing. And we are also going to release a new annotation processor soon to check dependency injections, so to do a few checks for performances. And so one of the good things is that if you want to create one, don't start from scratch. Don't spend too much time reading the API and even less reading the documentation, except if you want to do a postdoctorate about that, because it's really scholar. So what you should do is just try to find an annotation processor that you like, you know a bit about, and start by just copy and pasting. And then you get started just with a kernel that works, and then you make it grow and make it your own annotation processor. But if you start from scratch, headache guaranteed. One of the things that is cool with annotation processing is that we can generate code. We're going to talk about that in a few seconds. So just to give you an example, a very small example of what annotation processing looks like. So you have a type element, which is an enclosing element. you ask an element to get the enclosing element. So you think, oh yeah, maybe I'm in a class, it's the inner class, I want to get the outer class, so cool. But you have to cast it. Oh yeah, why? No one knows. And then you will ask it to a type element to get all the executable elements, which is kind of a name for methods, but not exactly. And then you get a set of modifiers and so on and so on. So all the things are named completely differently all the time. It's not a one-to-one notion. It's not that methods have a new name, no. It's that methods are actually represented in a different way and an executable element as different things that a method doesn't have or not everything that the method has. So it's really difficult to learn. But what is cool is that you can generate code. And that's really the key for performances in both Dagger and Toothpick and all the modern libraries of dependency injection. So you remember, Danny explained that with Dagger, when you want to create a module, you have some annotation porn, as he said. So at module, when you create the class module, then at provides for every method that does a binding. So you just write that, and internally, the annotation processor of Dagger, which is called Dagger compiler, is going to generate this code. So it will generate a slides module display out factory. So if we come back to the previous slides, you see here, it's just about creating a class instance that is called display out. That's it. So we generate all this code inside Dagger. So basically, it's just going to create a factory that will use the code that you provided in your module. So here you can see it's a factory of display out. We want to create instances of display out. So we have to customize the factory to receive the module that contains your code that knows how to create the display out. You will also need a dependency, which was a resolution. And so there is a provider of a resolution. And then there is finally the get method at the very bottom of the slide, which is what you actually want to do, which is when I call get on this factory, I will use the resolution provider inside the component and get a new instance of display out using the module, the code of the module that you created. So all of the code that is generated is actually just created to call your code that you annotated. That's the philosophy of Dagger. And so they generate codes, for modules, a lot of other things, we will come back to that. In Toothpick, the approach is quite different. So there are no modules with annotations like that, no components. What you do is that you take your class UCSB display out, and you just @inject the constructor. So you say Toothpick, when I want to create a new instance, I will have to use this constructor. And then internally, the compiler, the annotation processor, is just going to generate this code. So we want to create an instance of a display out inside the scope, and we are just calling to call the constructor that you annotated. So the approaches are a bit different. So you see, both of them generate code to call your code, but in Toothpick you just annotate it. In Dagger you have to explicitly write all the news yourself, especially if you want to test them, to override them. So in both libraries, Dagger and Toothpick, basically code generation is used to create the factories and the member injectors. Factories are just entities responsible for creating instances. You remember calling a constructor by reflection was super slow. That is the replacement. So we create factories that know how to create instances without reflection. The same is true for member injectors. So assigning a field, getting a field, setting a field was slow with reflection. So we generate code that knows how to assign members to your entities. Moreover, Dagger will generate code for modules and components, which don't exist really in Toothpick, or not in the same way for modules. But Toothpick can also generate registries if you're looking for crazy performances. Globally, the idea is that Dagger generates a static graph. So it means that it's a code, the code that is generated is only going to call generated code. So the whole generated code is actually going to create a tree, a graph, that only calls the code that is generated. So it's completely circular, what is created by annotation processing. This is very efficient. It means that as soon as you start creating a graph of dependencies, then everything is completely wired. The wiring is static, and it's very hard to modify. That's why you cannot use Dagger really for testing. You cannot replace one implementation by a mock. It's super hard to do using dependency injection in Dagger, because everything is wired together by the compiler. On the other hand, Toothpick generates a graph which is dynamic. So the generated code will actually call runtime code of Toothpick to every time ask who is binding. So we just look into an hash map, big O of 1, no real performance issues there. So we call the runtime code of Toothpick from the generated code. So it's a bit less efficient, especially if you have a large number of injections. As Danny said, at Groupon, we have like 1,000 injection at the beginning. It's quite a big application. If you would like to count in your application, I would be surprised if most of them are over 500 injections. So it's a bit less efficient, but it depends on a range. Below 1,000 injection, Toothpick is actually more efficient. But this approach is also much more flexible. This is why we're able to change all the bindings when we want to test. And we can use DI for testing. So that's the main difference. Like an hybrid approach where you can change the graph, where you can change the implementations. Finally, there are a few alternatives. So we have been through reflection. We could see that it's slow. It's not really appropriate for Android. We could see also that there is annotation processing as an alternative, a solution to escape the reflection hell. But there are other techniques that could be used to realize dependency injection frameworks. So here, if you look at the editing cycle from the Java source to the application, you can see that we can use annotation processing, we can use reflection on the right, but we could also use AST manipulations. That's the approach that some people took for Lombok, for instance. Lombok, or there are a few libraries like a parseller from a guy from Poland, Message, that uses AST manipulation. So basically it's abstract syntax trees, an internal representation of the compiler. There are some issues, but it works well. We could use that for dependency injection as well. We could also use bytecode weaving, which is a very classical Java technology. But on Android, it didn't really work well. It was not adopted, mostly because of Jack and Jill, I would say. Now it's dropped. But as a replacement to bytecode weaving, there is the transform API. This can also be used to create dependency injection libraries. Proton is one example of that. Doesn't look to be very maintained, but it uses the transform API. And yeah, I will leave the conclusion to Danny between Dagger and Toothpick.
Okay, so just to sum up the things we just heard internally. So we look at Dagger and Toothpick, and just remember, like, the Dagger has this compile time scope verification, which is really helpful. I mean, it has crazy error messages, but at compile time, you know if your scope setup is correctly. Dagger is slightly more efficient, especially when it comes to a large number of injections. Toothpick, on the other hand, avoids a lot of the boilerplate code, the annotation point that we just saw. When it comes to testing, it is easier. There are some things that try to get around for Dagger and make Dagger better for testing, but just not meant for this. Well, Toothpick is this, every add inject is mocked to an add mock. This is really, really, really nice. And I think that Toothpick scopes are much more clearer. So if you have to write custom scope, think about maybe about Toothpick. That's it. Have a look at the library. I think Stephane will be happy if we start a library on GitHub.
Oh yeah.
And there's another talk for tomorrow. If you really want to look into Toothpick and want to hear more about it, there's a full talk about this tomorrow, I think. Mm-hmm. And we can open this for question. Yeah. I see a question over there.
Thank you. Any questions?
Thank you for your speech. I've got a question. Couple of questions. First question: does Toothpick support qualifiers? I mean, named dependencies.
Yeah. So all of this, the qualifiers that inject on constructors, fields, etc., the scope annotation, everything is part of the GSR, and both Toothpick and Dagger are full-fledged implementations of the GSR. So we support all that.
Okay. For example, Dagger supports lazy instantiation.
Same. And, yeah, we have that as well.
And what about producers?
Oh, we have providers.
I mean, Dagger allows to create dependencies in background.
Oh, you can do that, but it really depends on how you use it. You can combine your dependencies with Rx if you want. You could do that. Does it answer your question?
I get it. Thank you.
Yeah? Okay. Oh, by the way, we're going to the discussion zone right after the talk. So if you want to have more questions, we can proceed there.
Thanks, guys, for the talk. Can you please show the slide with the testing where you wire mocks into the graph?
In Dagger or Toothpick?
In Toothpick.
Okay.
So I have
let's go to this
really
one,
one question. Is there another way of replacing instances in the scope?
You mean to replace instances in the scope?
I mean, you write mock, add mock annotation. Is there...
or if you wanted to write a fake object of your own, like a stub object that you will write. Yeah, for sure, you can do that. The idea is that with the toothpick rule, there is a scope associated to the rule, and you can also install every module you want. And inside the module, you say, I want to bind this at the thing that I inject by my fake class, basically.
So the toothpick only use reflection to bind to the fields?
No, we use runtime. We don't use reflection at all. There is no reflection at all.
Okay, thanks.
I have a question regarding the name, because if you compare Dagger to Toothpick, it seems that Toothpick is less useful. You can just basically clean your teeth, and with Dagger you can prepare food and maybe use it as a weapon.
And yeah, you can
so
even
it
kill
seems
people.
that it's a younger brother or less useful thing.
But as I said, a good library is sharp, and a toothpick is much sharper than a dagger.
Anybody else?
Hi, thank you for the speech. It was quite nice to hear. I have a couple of questions. First of all, Dagger 2 recently presented to us an Android extension. Have you used it, and how do you feel about it?
So one of the things I know of about the Android extension to Dagger is the releasable singletons, for instance, and that's something we're going to do in Toothpick 2. So, because we also have this problem. For instance, at Groupon, we don't use any static classes, like the how do you call them? The util classes, basically. There is no constructor, only static methods. We don't do that. We create singletons because we want to mock the dependency. So we want to mock all the pieces of code. So in the end, when the application runs for a long time, you have a lot of singletons like that. So we want to be able to release them. So we are going to this direction as well, which is not very difficult. And in Toothpick 2, we are also going to change something related to the GSR implementation to make scopes even easier to use.
And
so
maybe
that,
can I add here? Because there is actually an extension for Android there, which is the smoothie module.
Oh, yeah, smoothie module,
So when you need one of those Android classes, one of those typical services or something, it's already there. There's one module that you can add, and everything is already wired up.
Yeah, so like the telephony manager, you can inject all that if you use the module. But if there are other things or there are aspects, I would be happy to discuss that in the discussion zone.
Thank you.
Yeah, thank you.
Thank you for the speech. And my question is that how do you actually test the annotation processors? So because I'm developing the annotation processor in real database, so the test is our core concern. So I'd like to know.
Okay, so there are two things that you should try to when you develop an annotation processor by yourself. The first one is Java Poet to generate code. So that's a library that has been written by Jake Wharton to create code, which is very convenient with a Fluent API and so on. So this one is really interesting. And also there is a testing library from Google to test annotation processors. So you do not really unit test them because it's very hard to create objects of the annotation API. So what you do is that you create a small text file inside a string, a Java file, and you expect the code that is generated, basically. And you can see that, all those libraries always have the same structure for testing, so you can get inspired from them.